Good morning. Today we're going to do some more with inverses. We're going to talk about the how to tell an inverse from a graph or table. Yesterday we learned how to convert an equation, a function equation to an inverse function, and how to restrict the domain if the function is not one-to-one to begin with. Today we're going to take the functions, tell you how to tell whether it's one-to-one from a table, and also how to interpret or how to find inverse values of an inverse function from a graph or table. So, Saham drives from home to work each morning. She noticed that the later she leaves, the longer her drive time will be. After careful analysis, Saham determined that if she leaves the house X minutes after 7 a.m., then she will arrive at work f of x equals 20 plus 5x minutes after 7 a.m. So it's a little bit of thinking here. This warm-up is on page 17 in your book. I need you to go ahead and stop the video, annotate this, and figure out, or try to figure out how to answer the questions here. Okay, so she leaves this function minutes after 7 a.m. So this is the time she will arrive at work, right? My dependent variable is the time she will arrive at work. So the dependent arrive time and the independent, the x, is the time she leaves. Okay, so we're required to create a table of values for f of x, this thing, starting with x equals 0 and ending at x equals 10 at 1 minute intervals. So x, f of x, starting at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so f of x, again, equaled, let's see, what did f of x equal? 20 plus 5x. So f of x equals 20 plus 5x. So if x equals 0, you can put this in your calculator and just copy the table, but hopefully you can do this mental math. If x equals 0, her arrive time would be 20 minutes after 7, right? That's the, no. Then she'll arrive at work that many minutes after 7 a.m. So she's going to be there 20 minutes after 7 a.m. If she leaves at 7:01, she'll be there at 25 minutes, because 20 plus 5 times 1 is 25. 20 plus 5 times 2 is 30. And we're noticing a pattern here. Since our slope is 5 in this problem, we should be increasing by 5. Every time we add 1 minutes of increments of 1 minute, we would increase our arrive time by 5 minutes. So it looks like traffic starts to get heavier the later she leaves from work. And from experience, I can tell you that's probably about right. So at 7, it's 55 minutes, 60, 65, 70. So if she leaves real late, she's going to get to work after 8 o'clock. So if she has to be to work by no later than 7:45, she can't leave any later than 5 minutes after 7. So the answer to the question would be, because if we look at the arrive time of 7:45, it looks like the leave time would be 5 minutes. So 7:05 is when she can leave and still get there on time. Okay, and I'm going to leave this table here and just go to the second question. Use the same equation to solve for the inverse. So to solve for the inverse function, we would have to switch. Well, first we replace. So I'm going to do this over here. I know you have your books, so I'm not going to leave those questions up there so I can show all my work in one place. So if we have the function and we change this to y and switch the x and y, we have x equals 20 plus 5y. Solve for x by subtracting 20 from both sides first. Remember, undo addition and subtraction first. These are not like terms, so that's x minus 20 equals 5y. Now divide everything by 5 because you undo multiplication by dividing. And this is 1, so I have y on this side, 1/5 x minus 4. 20 divided by 5 is 4. So if I write it in inverse form, it would be f negative 1 of x equals 1/5 x minus 4. So for question 2, see if I can grab that. Question 2 said to solve for the inverse, which we did, then create a table from x equals 20 to x equals 70 with x in 5-minute intervals. So x equals 20 to x equals 70 in 5-minute intervals. X equals 20. And it looks like, if you look at my output in this one, that becomes my input here. We talked about that in yesterday's lesson. Your output and input switch spots when you find the inverse of a function. Okay, so let's test this. If I input 20 into my inverse function, if x is 20, 1/5 of 20 is 4. So 4 minus 4 is 0. This ends up equaling 0. Now let's do 25. 1/5 of 25 is 5. 5 minus 4 is 1. So we're going to be going up by 1 here. Every time we increase our x by 5, our inverse increases by 1. And again, you could put that function in your calculator and get these answers also. 55 is 7, 60 is 8, 65 is 9, 70 is 10. So the question is, use this table to determine the time she must leave home in order to arrive at work no later than 7:45. So what time should she leave in order to arrive at work no later than 7:45? It's the same point, 7:05. So the answer to number 2 is 7:05. Question number 3 was compare the tables. How are they alike and how are they not alike? Well, they have the same values, it's just the input and output have been switched. That's what I would say. They're alike because the values are the same, but they're switched in the inverse. The input becomes the output in the inverse. Okay, so that's your warm-up. Now you're going to get your notes, and we're going to go through the notes and then come back to the book to do some more examples. So keep your book out because we're going to go back to page 18 later in the lesson. So, like I said at the beginning, if we don't know the formula or the equation, it's hard to find the inverse of a function, and typically in real life that happens all the time. But they have the data that they collected in an experiment, so they can almost always use the table or the graph to find the inverse, and that's what we're going to do today. So input and output always have, if a function is invertible, which means it's 1-to-1, we talked about that yesterday. So input and output are 1-to-1. That is, if an inverse exists for the function, it has to be 1-to-1. So we kind of added on to the fact that if it's not 1-to-1, the inverse does not exist. So we have to make it 1-to-1 by restricting the domain. We talked about that yesterday. In tomorrow's lesson, we're going to talk more about that. So you cannot have repeats among the inputs or outputs in order for it to be invertible. So in this quadratic function, you notice there's no repeats among the inputs, but we've got a repeat here in the outputs. And if you had more, if we went up more in this column, you would see more repeats in the y column. So check your one-to-one correspondence by looking at your points. Either look at the table or the set of points. So let's look at our x values. 1, 3, -3, -2, and 0. There's no repeats. 2, 5, 4, 5, and 5, you have repeats. So this is not invertible because it's not 1-to-1. Okay, check for repeats. If there are repeats in the input or output, the function is not one-to-one and not invertible. I'll let you fill in your notes. So let's put that set of values in a table. What is the value? This is not invertible because we have repeats in the f of x column, our output column. Remember, this is input, output. So, but I can interpret the value of the function at a certain what the function equals at a certain value of x from the table, because if x is -2, I know y, or f of x, is 5. So f of -2 is 5. And then f of 3, I go up here, and f of 3 is also 5. So it's not invertible because it's a function, because for every x there's exactly one y. There's no repeats in the x column, but there are repeats in the y column. So in other words, it's not invertible if there's repeats in both columns, or in the y column. So to find the inverse from a table, check to make sure the function is one-to-one, switch the columns. Label the output column f inverse of x. So I'll give you a second if you want to copy this down on your paper. You might want to stop the video, copy that down. When we come back, we're going to label the output column f -1 of x, f inverse x, and this is still x. But now this was the output from over here. So I'm going to switch the columns basically. Take 0, 1, 3, 2, and 5, the output, and now make it my input. And then I'm going to do the same thing with the input from this. It becomes the output from this. So it's going to be 2, 3, 4, 1, 0. So we're just switching the x and y just like we did yesterday. So what would f inverse of 1 equal? Well, start in the 1, and it equals 3. What's the f inverse of 5? 0. So that's how you find the inverse values of a function from a table. We're going to skip that for this class. Okay, so finding the value of an inverse from a graph. This graph shows the values from that table we just did. And the black ones are f of x. So these are f of x. And the gray is the inverse f of x, f inverse of x. Okay, so always the function and its inverse, if I graph the function f of x, these 5 points, when I graph the inverse, the points are reflected across the line y equals x. So for instance, this is 4, 3 if it's f of x, and it's now 3, 4 if it's the inverse of x. So it's always reflected across this line y equals x. Well, the line y equals x just has the points where all the x's and y's have the same value. So notice 0, 0, 1, 1, 2, 2. So if you had to plot it, you could just plot a couple points and just draw a line through it. We're going to have to do that for this for this unit. So I want you to be able to understand what I'm talking about when I say to plot the line y equals x. But in this slide, it's just important to see that these points are all reflected across the line. This one is 5, 0, 0, 5. This one is 3, 1, 1, 3, etc. So all my points are just reflected across the line from the function to its inverse. Now, I apologize because in your notes, this graph is very difficult to see. So you may have to stop the video while we talk about this part of the lesson. If the function is invertible, a graph may be used to find the inverse. So if I want to find the f inverse of 4, I'm just going to go backwards from 4, because this is f of x. So on this line, if I start at 2, I go to 4. If I want the inverse, then I would go backwards from the f of x down to the x. So I start at 4, go to the graph, and then drop a line down to the x-axis, and I can see that the value is 2. So the value of the inverse is 2. So it says to find the f inverse of 6. F inverse of 6. So we start at 6, go to the graph, drop a line down. You don't have to draw it. I'm just showing you visually so you can just follow what I'm doing. So f inverse of 6 equals 4. And the next one is f inverse of 5. Let's do that in orange. F inverse of 5. So we go to 5, go to the graph, drop your line down, and that is not labeled, but if I see this is 2 and this is 4, halfway between must be 3. So this is 3. Now the next one says find f of 1.5. If I want f of 1.5, I start on the x-axis because x equals 1.5. So I start on the x-axis at 1.5. Well, here's 1, so this must be 1.5. Now I go up to the graph, and that's here, and I go over to the f of x, and so that equals 3. And now the last one, f of 4.5. F of 4.5. So now I'm looking for x equals 4.5. So I go to 4.5, go up, and I'm not going to draw it straight, but I'm pretty good. And then over to the y-axis, and it looks like that would be 9. So this axis is your f of x. This axis was your x. They have it labeled for you there. So y is f of x, same thing. So if you're using a graph and you need to read carefully what the graph is a graph of, because this is a graph of f of x. If this were a graph of f inverse x, then this would all be backwards. We're going to see an example of that in a minute. So we did that. And to graph an inverse, if you have the graph of the function, you just draw the line y equals x. Find a couple points on the graph. So the coordinate to this point are 2, 4. So I know 4, 2 is on the graph. Okay, so there's one point. And then find another point. Well, they use 2, 2. No. What did they use? 2, 4. Sorry. Another point on the graph, you might use this one. 6, 4. So it should be 4, 6. And that's also on the graph. So you can just switch the variables. So this is the line y equals x. Graph the inverse, reflect the graph across that line y equals x. Okay. Be careful to read the problem carefully and what you're given carefully. So make sure you're using if you are given the graph of a function, don't use the inverse to find the value of the function. And look in the correct row and look on the right axis when you're interpreting these functions. So on page 18, I told you to keep your book because you're going to go back to page 18. Use a table to find f of 1 and f of 2, as well as f inverse of 3 and f inverse of 4. Well, to get the inverse, remember we have to have x and f inverse of x. So these numbers, the f of x numbers become my input. 3, 4, 1, 5, 0, 2, 0, 1, 2, 3, 4, 5. So this is my inverse, this is the f of x. So for f of 1, well, I guess f of 1, you can do these one at a time in your book. So this would be the first question in your book. Determine whether the inverse exists. Oh, I forgot to do that. There's no repeats in the X column or the Y column, so yes, number 1, yes, it is 1 to 1, so we're good on that. So number 2, are they numbered? Yeah, find the value of f of 1. So I start with the f of x graph or table. So if I'm using f of f, then I want to go to the f of x table. So I start at 1. That means the value of the function at 1 is 4. Number 3 says to find the value of f of 2. So I'm using the same table, and that equals 1, 2, 1. Number 4, find f inverse of 3. Well, f inverse of 3, I need the inverse function table, would be 0. And number 5, find f inverse of 4, same table, and it's going to be 1. And then it says to summarize your findings. So I want you to stop the video and explain in words how you would find the value of a function at a certain value of x for the function and for its inverse. You just explain that in your own words. I'm not even going to give you the right or wrong answer. Just think about how you would explain that in your own words, because for good notes you need to know why these things work the way they do, because if you come back to this in 3 or 4 days, you're not going to know why you wrote these answers. Well, I will go ahead and summarize. So to find f of x, this is you probably would have wanted to write something like this in your summarize. To find f of x, start, let's say use table for f of x, and find x, your input, then use the y value that goes with it. That's one way of putting it. I mean, if you have it in your own words of some way, and to find the inverse, f inverse of x, use the other table. Use table for f inverse of x, which has input and output switched. Okay, so you would still do the same thing after that. You just use the other table. Okay, example 2 gives us a graph of a function. So we have this graph we need f of 1, f of 2, f inverse of 3, and f inverse of 4. So look at the graph. Right here we know this is the graph of f of x. They told us that up here too, but be careful because it's easy to make a mistake on this. F of 1, so if I need f of 1, I would start on the x-axis, because x is 1, x equals 1, go up and over, and that gives me 2. So that's 2. Up and over. I need f of 2, so now x equals 2, and I go up from 2 and over, and it equals 3. I need f inverse of 3, f inverse of 3, so now I'm going backwards from 3 down to the x-axis, so that equals 2. F inverse of 3 equals 2, which makes sense because those two are, that point would just be switched. What about f inverse of 4? So now I start at 4, go up and over, that looks like that's 5. Okay, the next example, well, and you can summarize if you want to how to find f of x using a graph. And then example 3, use the graph of the inverse function f inverse x to find f of 1, f of 2, f inverse 3, and f inverse 4. So stop the video and try this on your own. This is oh, well, don't stop the video. If you did, sorry. F inverse of x, you can try it. This is x, and this is f inverse of x. So if I need f of x, f of 1, I'm going backwards because this is the graph of the inverse. So remember that the f of x would be going backwards to get our values. So I would start at 1 and go down. So that's going to be 0. And f of 2 is the same thing. I start on the y-axis, go over and down, and that equals 3. But if I need f inverse of 3, it should be 2. Let's see. F inverse of 3, now I'm going from x, because now this is the graph of the inverse, so x equals 3. So now I'm going up and over, and that equals 2. And the last one was f inverse of 3. No, f inverse of 4, sorry. So I go to 4 on the x column because x equals 4. F inverse of 4 equals 3. The next, oh, they just give you more graphs. The next two examples are more real-world examples. Well, this example is anyways. Daniel's cell phone company offers a flat rate, unlimited texting plan for $25 per month. This is kind of an old thing because now everybody gets their text unlimited. But okay, Daniel's cost per text in a given month depends on the number of texts he sent and received that month, according to the function f of x shown in the table. Use the table to find and interpret f inverse of 0.05, which would be 5/100ths of a dollar or 5 cents. So to get a text for 5 cents, you would have to make this many calls. So it says use to interpret. That means to have texts cost 5 cents, he needs to make 500 texts, which doesn't take long. Most of you do that in a week per month. Okay, so if I say interpret, you need to write a sentence about the graph. Don't just tell me 500 texts. Write a sentence. In the last example, use the graph of the function to graph the inverse function. Okay, so I want to graph the inverse. The first thing you need to do is draw the line y equals x. Remember that was 0, 0, 1, 1, 2, 2, etc. So you're going to have a line like this. So that's that line, y equals x. I need to flip this function over that line. Okay, so I need a couple points on that line. So x, f of x. To draw a line, you only need 2 points. So let's pick 1 point on this line right now. Looks like 8, 6 is a point. And what's another point on the line? 0, 4. That's an easy one. 0, 4. Okay, so to do my inverse, I'm just going to flip those around. X, f inverse of x. Just flip your columns. So 6, 4, 8, 0. So we'll graph 6, 8, and 4, 4, 0. So now I'm going to connect those. Kind of hard to do because I have a shadow. And make that line. So there's your line f inverse of x. So this one is f of x, this will be f inverse of x. Now I want to use that graph to find the inverse, the value of inverse 7. Well, it looks like it's not exactly a number, so it's somewhere between around, what is this? 5.5 is probably around 5.5-ish. If my graph was exactly correct, it would probably be 5.5. Okay, so your assignment is on pages, because there's a bunch of graphs and tables, so it takes up more pages, but don't panic about that. I want you to do 1 through 10 on pages 21 through 25.